Yeah, I saw someone crash their car and I was a little scared. So.
Yeah. So.
I cried. My mom's like, yeah.
We are in major delay on this thing, but you know what? We'll see if it works. I'll upload the video later. Easy, I suppose. All right. So, welcome. I don't have to fail all of you because Maddie dressed up as me today, so thank her.
Oh, yeah.
Let's review for your quiz tomorrow, which I think is going to go really well, actually, if you study a little bit. I know it's Halloween. Don't get spooked tomorrow. I thought about dressing up as your quiz today, like literally like printing it out, but like gigantic.
You should.
That'd be kind of funny. Well, trick-or-treating's tomorrow, so.
That's true.
Yeah. Yeah.
She's not wrong.
I'm going to go out and drive around and see how many people didn't get the memo. Like if I just see like little kids trick-or-treating. That'd be pretty fun.
I bet she'll do that. I bet she'll do
I'm
that.
gonna be sure. At least
Are you-
one person.
Yeah, probably out in the snow.
I ain't gonna lie, I threw it from back there.
What is slope?
Slope is rise and run.
Thank you. So we know that it's the rise over the run.
Where's Brandon?
He's on a trip. So rise over run is what slope is. The rise is what? What is rise?
Line, vertical.
Vertical, right? The change in vertical, right? So the change in y, delta y and delta x, right? How much we've gone up or down. Delta x means how much we've changed left to right, right? Cool. Now, we know that change is the same thing as distance. Distance is subtraction. Which variable deals with the up and down?
Y.
I ask the questions.
You can't do that.
I laugh when I pass my quiz tomorrow. That's so funny.
So now we need to talk about why these are what they are. Subtracting the x's, right? Distance is subtraction, so we're talking about distance. What kind of distance does that represent? You're right. What kind of distance? I mean, it's x's. What do the x's have to do with? Across, horizontal, right? So horizontal distance. And that means the top part is also distance. What kind of distance, though? Vertical.
That was a loud crunch.
Yeah, they're kind of
That's impressive. What we eating?
Takis.
Takis? Okay. Respect. That's it. Turn the page. Give you a lot. Yeah, draw a picture.
Whoa, I'm missing a page.
On the back of the first page.
We're on page 2.
Whoa, whoa, sir.
Double-sided, baby.
Maddie didn't even get it back.
Maddie didn't get it back.
Maddie
That's because
was
Maddie
supposed
doesn't
to
have to take any quiz the rest of the year because she dressed up as me. So,
If I would have passed back, I would have got smacked in the head.
like, you can fill this out.
Whoa! I've never made a dinner.
You're so talkative today. You having a good day?
I've never made a dinner.
Yeah, never? Oh, make one later. Yes. Yeah, throw it.
If we go
I
out,
don't-
it'd be a great day.
Is it okay if I go up to my locker, get my water bottle, fill it, and like,
That's what I already
So what you're asking me is, can you go to the bathroom and use your Jewel?
no.
The answer is
I don't
yes.
have a
Who
Jewel.
got a jewel pot?
All right, go ahead. Yep, go ahead.
What's your favorite jewel
It's
pie?
on the top floor,
Cucumber.
so I didn't know.
Ew! That's okay.
I don't even think of
It is the thing. I don't.
I like
I know I'm like super rad and
I
hardcore, but
original
like, yeah,
tobacco.
yeah, that's
I like good old.
that's the flavor for me. Drugs are bad.
I love
Okay.
colon cancer.
Can you sit down? What are you doing
I
here?
like the air.
I know you do.
Huge Joel Nate.
Can you handle these? Okay. Anyway,
Oh,
we're just joking. All right.
Name of her is from
There are drugs and then there are drugs. We've talked about this, okay? All right. So,
No, of course not.
I'll ground you.
what we're going to do now
Yeah.
on the next page is we're going to find the slope of these two lines.
Not your buddy.
This line is the line between these 2 points, okay? So, how do we find the slope? Well, it's the change vertical over the change of horizontal, right? So, how much did I change vertically? We're on page 2, back side. So, the question is, if I'm on -2 and I went to -1, how did I change?
Added one.
I added 1. So our slope is up 1 for vertical change, right? Going from here to here, of course. If you went the other direction, you'd get a negative, right? Just be consistent. If I start on 0 and I go to -2, how much did I change horizontally? -2. So my slope is 1 over -2. There are lots of ways I could write that. I could also write it like this. I could also write it like this. They're all the same, right? One negative sign. So that's the slope of the left equation, the left line, right? The right line, let's find its slope. Same dumb crap. I'm starting at -3 and I'm going to -4. How did I change? Down 1. I'm starting at -1 and I'm going to -3. I went down 2. Really, it's left because we're talking left and right here, but you know, whatever. Words are hard, math is easy. We know that's the same thing as 1 over 2 because 2 negatives make a positive when you divide, right? Cool. So that's the slope of line 2. Now we need to tell whether these lines would be perpendicular, parallel, or askew. Remember, askew just means they hit at some random angle, right? Parallel means they never intersect because they have the same angle. Perpendicular means they hit at 90 degrees. And anything else is askew, right? So we know lines are parallel when their equations have the same slope. We know lines are perpendicular when they are opposite reciprocals of each other, right? Negate and flip. And when it's neither of those, well, they're just going to intersect at some point, right? So they call them askew, right? So are these the same slope? They're close, but not quite, right? That means flip it and negate it. So if you can flip one slope and change the sign, and they're the same, then it's perpendicular. Remember the flip and negate? Flip and change the sign? Okay, so are they parallel? No, because they're different, right? Are they perpendicular? Meaning if I flip this guy, I get 2, right? And then change the sign to -2. Is this guy -2? No, then they're not perpendicular either, okay? Remember, if you can flip it and change the sign, then they're perpendicular. So these are neither, which means they are askew. Okay? Askew. Let us look at number 4. Same dumb crap. Going from -5 to +1, that's our rise, right? So I went from -5 to 1. Think about that. I'm at -5. I got to go up to 1. I went up 6. I'm on 7. I'm going to 4. I subtracted 3, so I went left 3, right? What's 6 divided by 3? 2, and it's negative, right? So our slope is -2. Line 2 slope. 4 going to 2. -2. 1 going to 2. We added 1. Are you okay, Maddie?
Yes.
Okay, gotcha. Just got a little bit of Takis on you. I thought you were like
Yeah.
doing this.
That too.
Okay. Are the slopes the same? Oh yeah, which means they're parallel. Maddie, an example of perpendicular slope would be if we got something like this. -1/3 for one slope, and we got +3 for the other. These would be perpendicular because if you flip this guy, you get -3, right? Change the sign, you get 3. Does that make more sense now?
Yeah.
So that would be an example of perpendicular, yeah.
Can you briefly explain 2 or 3? Because like, I was not.
2 or 3, yep. Okay, so what we did is for 2, we found the slope by figuring out how much we changed vertically, right? I'm on -2, I went to -1, so I added 1, right? I'm on 0, I go to -2, I subtracted 2. So our slope is -0.5. Cool? Slope for this guy, on -3 going to -4, so I went down 1. I'm on -1, I went to -3, so I subtracted 2. 2 negatives make a positive. Slopes are different, so they're not parallel. Are they opposite reciprocals?
So if they're like
Mm-hmm.
the same but opposite signs.
No. I know what you're thinking. It's a coincidence, okay? So here's what it is. When they're parallel, they're exactly the same, right? Makes sense? When they're perpendicular, they're flipping the gates of each other, right? And if it's neither,
It's askew.
they're askew. That's the name for they just hit at a random angle, right? Because if they're not parallel, they're going to intersect at some point. But it's going to be some random angle. It's not 90, right?
So if I were to do there instead of
Askew.
yeah, maybe at that,
Yes.
on the test. like-
I will allow it because I changed the directions from the homework and Corinne does the homework, yes.
Wait, what?
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 Are you joking?
That's the time.
She's okay, YouTube. She's fine.
It's like something right here.
She's eating Takis.
Respect.
You need me to call the ambulance?
Yes.
Turn the page.
I need to use your phone.
All right, it says write the slope-intercept form of the equation of the line described. First of all, slope-intercept form. What's that? It's the one with the slope and the intercept, right?
That's the distance, I think.
Nope. Slope-intercept form. It's the one with the slope and the intercept.
Y2 minus.
Nope. That's slope formula. That's what slope is. M equals, right?
Y equals,
Oh, you can't do that.
What?
No, I'm playing.
I guess slope x is b.
Slope x plus b. Mx plus b. Why do they call that slope-intercept form? Because, Maddie,
So the slope and
that's the slope, and that's the intercept. Now, what intercept is that? The x-intercept or the y-intercept? There's our slope. There's the y-intercept. It's the y-intercept. So when they say slope-intercept form, think about what it means. It's the one with the slope and the intercept in it. Cool. So this is in slope-intercept form. There's our slope. There's the intercept. We want a line that's parallel to that. If the lines are parallel, what do we know about their slopes?
They equal the same.
The slopes will be the same. So our line that's parallel to that is going to be y equals 3/4 x and some y-intercept, right? Again, for them to be parallel, the only thing we care about is slope. But we don't want it just to be parallel. We also want it to go through this point. Okay? Now, for a point to be on the line, it means that that point is a solution of the equation. Meaning that when we plug in -4 for x, the equation for that line should also get us 6 for y. So what does b have to be so that when we plug in -4, we get 6? That's the question we're asking, right? What equation must that be? Well, to figure that out, we can just plug in -4 and 6. 6 for y and -4 for x. And then we can figure out what the y-intercept has to be. Okay. Multiplying fractions. We can either times by the top first or divide by the bottom first. Which do you want to do? Times by the top. Very popular choice. 3 times -4 is -12. Divide by 4. -3. Again, we know our answer has to be negative. Look, we have a positive times a negative here. So it's going to be a -3. Could you have divided by the bottom first? Yes. Here's what would have happened. -4 divided by 4 is -1 times 3 is -3. Right? Get you same thing. You have options. If we add 3 to both sides, we find out that b has to be 9, which means our equation is going to have 9 for b. So it's going to be y equals 3/4 x plus 9. So that is the equation of the line that is parallel to the first equation and goes through -4, 6. Okay? Are you smelling what I'm stepping in? Same slope as the line they give us, right? Because they want it to be parallel. We don't know what the y-intercept is, but we can figure it out by plugging in x and y. b is 9. So our y-intercept should have been 9.
I get it.
Mm-hmm.
Oh, where did the B go? And 9 equals B.
Here's b. I plugged in 4 and -4 and 6, right? I did math. B is 9.
Okay. Oh, okay, I get it.
No, it's okay. It's a problem this small, but if we didn't take the time to do it, it would have been impossible for you. It's not that you're dumb, you just didn't see it.
Are you supposed to graph these?
Yes, so now we're going to graph that. y-intercept is 9, right? So we go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And our slope is 3 over 4, right?
Yep.
So that's how we're going to get our second point. And then we can draw our line. So up 3 over 4. 1, 2, 3, 4. Now, could we have gone down 3, back 4? Sure, right? It's the same thing. Negative 3 over negative 4 is the same thing as positive 3 over positive 4, right? Either way, all you need are 2 points, but I did 3.
Oh, really?
Yep.
I need the protractor.
That's right. So there's our line. Would that be parallel to the original line? Yep, because they have the same slope. Right? Cool? All right. Let's take a look at number 9. Calc students can do number 7. They get that. They know slope-intercept form, y equals mx plus b, right? They got that memorized, do the steps, blah, 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 right? 9, only you guys will get. And it's not because calc students are dumb, although I think they kind of are. You guys know what this means.
No.
And so you're going to be able to logic your way through it, okay? So we want a line that's parallel to x equals 5. So what does x equals 5 look like as a line? Well, x equals 5 is here. 1, 2, 3, 4, 5. That's where x equals 5, right? Now we want a line, meaning we want all the points where x is 5. So give me a coordinate where x is 5. Corinne. A coordinate where x is 5. 5, 3. 5, comma 3. 1, 2, 3. There's 5, comma 3. Joey, give me a coordinate where x is 5.
5,
Ooh, creative. -5. 1, 2, 3, 4, 5. So as you can see, the line where all the points are 5 for x is going to be a vertical line, right? Okay, so we want a line that's parallel to that. So our parallel line is also going to be vertical, right? Okay. It's going to be perfectly vertical, and it has to go through this point, right? Isn't that what they say? So here's -7, 6. There's -7, comma 6. 1, 2, 3, 4, 5, 6. So it has to be vertical and it has to go through that point, right? Because that's what parallel means. They never intersect. So I'm going to draw that. And then from that drawing, I'm going to figure out what the equation has to be. So this line is where x always equals 5. Let's check out these points. What do they all have in common? X always equals -7, right? We've got -7, comma 0, -7, comma 2, -7, comma 5 here, right? We've got all those points. They all have -7 for x. So the equation and the answer is x equals -7. It's the line where x is always -7. There's no relationship between x and y here. Y is whatever it wants to be. X is just always -7. This can be really easy if you know what you're doing. If you don't know what you're doing, even if you're a calc student, you're not going to know how to do this. But you guys know what it means. X equals 5. Well, here's all the points where x is 5. I need it to go through -7, comma 6. Well, that's where all the points are going to be -7 for x. So x equals -7. That's the equation of that line.
What goes y equals?
Turn the page. How about y equals -2? Maddie. You are a mess. All right. Y equals -2. Hashtag pray for Maddie 2019. All right. There's nothing wrong with her. She just,
Is it?
All right. Y equals -2. Okay, well, here's where y is -2, right? Y-axis, there's -2. We want all the points where y is -2. That's 0, -2, right? What about 1, -2? Well, that's here. What kind of line is this going to be? Horizontal. You see what I'm saying? All the points where y is -2, it's going to be a horizontal line. There they are, all the points where y is -2.
So is y gonna
Which one are you on?
10.
so is y gonna equal -8?
That's it.
Well, we want the line to be parallel to that, so it's going to be also horizontal. Let me walk through it, okay? Pause for a second.
So just,
Yeah.
okay, just says like, whatever variable
X or Y, yeah.
Just whatever X or Y.
Corinne, that's true for parallel but not perpendicular. Okay? So what I want you to do is not memorize this. Okay? Think about what it means. Okay? Could you memorize it? Yeah, but I think you might screw it up. And then if you don't know what it means, you're going to be like, okay, which one is it? And it's going to be a coin toss. Okay? So I'm going to walk through it. So bear with me. You're right. That is how it works for this one, okay? But try to figure out why that is. So we want a line that's parallel to the blue line. So if the blue line's perfectly horizontal, our parallel line better be perfectly horizontal as well, right? We want it to go through -1, -8. Are you okay, Ivy? Are you sure?
Yeah, I'm trying to
Sorry, I don't have any more caffeine. Okay. -1, -8. Yeah, you must have gotten up really early to get all that taken care of and done. All right. God bless you, child.
God bless.
There's -1, -8. Hashtag. We want our line to go through that point and be parallel.
Whoa.
So it's going to look like this, right? Now, Corinne, instead of memorizing that, oh yeah, we just look at the thing, okay? All the points on this line have something in common. And it's where y is -8, right? We've got 1 -8 here. We've got 3 -8, right? Okay? So the line is going to be where y is always -8. That's the equation, okay? And yeah, you can look at that because it's parallel.
Well, I meant like just for parallel.
Yeah, just for parallel. For perpendicular, what do you think it's going to be? Opposite, right? Whatever the x is when we're looking at y here. Does that make sense?
Wait, so what would?
Let's take a look at number 13. No, 14. 14. We'll do 13 and 14. How about that? All right. Perpendicular now, right?
Yeah.
So the slopes aren't going to be the same. We're going to jump back to hit those other ones too. Sorry, guys. Your packet is really similar to regular geometry, right? It's just the numbers are changed. So I'm like jumping around. My bad. And by numbers, I mean like the question numbers. Like otherwise, it's the same. That was great. All right. So 13. It says perpendicular to y equals 6. Well, what is y equals 6? Well, here's where y equals 6. Right? Where are all the other points where y equals 6? Well, 1, 6, 2, 6, right? All these guys. So it's going to be a horizontal line, right? Y equals 6 is horizontal. Now, for this question, do they want us to have a perpendicular line or a parallel line? Which one do they want? Perpendicular. Right? So it's not going to be horizontal because that would be parallel, right? It's going to be what? Vertical. I know, right? Please, murder me. I know, kill me now. Put me out of my misery, right? YouTube, unsubscribe, unlike, leave a mean comment.
Got that on camera.
I know, right?
You know that, right?
What?
That never works.
No, ban me, YouTube.
That never
All right,
works.
well, I try. Yeah, demonetize me. That's right. Demonetize this video right now. All right, so y equals 6 is this line. We want a line that's vertical and goes through the point 0, 0, right? So here's 0, 0. Vertical to make it perpendicular, right?
Sure.
There it is. What is the equation of that line? Now think carefully. Think before you answer. All of the points on the red line have what in common? Which variable, x or y? Think carefully. X is 0. See how y is different? There's 1, 0, 2, 0, right? So that's where x is always 0. So x is always 0 is the equation of the line that's perpendicular to y equals 6. And again, Corinne, right? Perpendicular, see how that's a y? We look at the x.
So for this one, it would be y equals.
You'll forget that by the time the final runs around, but if you know what this means, you'll be okay. Okay. Let's look at 14. Corinne has a prediction. She says that it's going to be y equals -1, and she's correct. It will be, because it has to go through -3, -1, and we want it to be perpendicular to this guy. But let's go through the logic. X equals 0. Here's where x is 0.
Horizontal.
Pause. Here's where x is 0. We want all the points where x is 0. So like 0, -1, 0, +1, right? It's going to be vertical because Maddie knows what's going on.
Ooh, I'm a scumbag.
Yep. Oh, yeah, I've decided to not call you scumbags anymore. I've decided to call you all Tide Pods.
Oh my god, remember when we used to
That's disrespectful.
You're all Tide Pods.
Wait, when was that?
Because when I die, and I will, we all die someday, it'll be your fault.
My fault.
Mm-hmm.
Death by scumbags.
Death by Tide Pods. All right.
Oh, 'cause
Yep.
we're gonna-
You are all my Tide Pods, yes. All right,
Or
so.
dual pods. I be your dual pod.
Can I be your
Okay.
jewel pod?
That sounds like affectionate, and I'm not
Oh, wait,
affectionate,
never
okay? Right? I hate all of you.
No, but dual pods can kill you.
Good point.
About how she had been dueling for 2 years and now she has like lung cancer.
Yeah.
Who hasn't even
Like,
been
she
around
has
for 2 years?
severe lung cancer.
I saw this one thing
Guys,
where it's-
cigarettes are bad, and they're really awful for you. Like, again, we have drugs, and then there's drugs.
That's why you gotta
Don't
smoke
smoke.
ganja.
Don't smoke.
The health
Okay.
benefits.
All right. Anyway,
We
we want a line that's perpendicular to this. So if this guy's vertical, and we want perpendicular, our other line's going to be what? We want perpendicular. This guy's vertical. It's got to be horizontal to hit at 90, right?
Yes,
So
sir.
we want a point that a line that goes through -3, -1. Here's a -3, -1, and we want it to be horizontal, so it's perpendicular, right? I keep grabbing purple for perpendicular.
That's a good color scheme right there.
It's just how my brain works. All right, so what's the equation of the red line? Well, every point on this line has something in common. We've got 1, -1, we've got 2, -1, we've got 3, -1. They all have -1 for y.
Oh, really?
See what I'm saying? Crin's like, I'm just going to memorize this, whatever. Respect, Crin. Respect.
Respect.
None. You're all good.
How do these have
Well, we
that?
totally skipped over these ones. Why?
Oh, good point. I did want to go back. Can we flip to number 11? We're on page
So,
4, number
where
11.
is the first page? Alright, got it.
I don't know. What
Okay. Again, we're doing perpendicular, but this time we have a y equals mx plus b. Okay. So if we want perpendicular, what do we know about the slopes? Are they going to be the same? No, that's parallel, right? Perpendicular couldn't be more different. So we flip it and negate it. So what's the slope of this guy?
-1/3.
-1/3. I'll zoom in.
Heck.
So our perpendicular slope is going to be flip and negate it. What happens when you flip a third?
It'd be 3 over
You get
1.
3, right? Now, do we want it to be positive or negative?
Positive.
Positive. Change the sign, right? So our slope is going to be 3 for our equation. A line that is perpendicular to this guy is going to be y equals 3x plus b. We don't know what the b is yet, but we can figure that out. It depends on what point they want us to send it through, right? They want us to send it through 5, -2, which means that when we plug in 5, we should expect -2 for y. So the question is, what does b have to be so that when we plug in 5, we get -2 for y, right? Well, we can solve for that. When we plug in 5 for x, what does b have to be to make y -2? That's what we're asking, right? So 3 times 5 is 15. If we subtract 15 to move it over, because it's positive, we get -17. So the equation of the line that we're going to graph is really going to be y equals 3x minus 17, right? Again, the original equation I wrote up here just represents all the possible equations it could be, right? Anything with a 3x slope, it's going to be parallel, or perpendicular, I should say. This one is not only perpendicular because of its slope, but also goes through the correct point. Okay?
How would we graph that?
Exactly, right? -17 is way down here. So we need to be clever. How would we graph that?
Just go by twos.
Go by 2s? What do you mean?
Like,
Oh, yeah, 2.
for every one line, just say it's 2. And
Oh,
then
we could
have
label it
time to
differently.
clarify.
That's true. That works. I don't like that because 17 is an even number and it's going to put it in like the middle of something. That's going to be gross.
So
Odd
it's
number.
odd.
Yeah, odd.
She's rude today. She
Corinne.
had too much popcorn in
Take
this
her off
Palmer's
the
class.
good note board.
No, we love Corinne. Okay, we love Corinne. The sass is what makes Corinne Corinne. All right. So Corinne's right. That's one way to do it. I don't think that's the best way to do it.
How about we
This point,
don't do
isn't this point on the line?
it? Yeah,
Isn't that what we wanted?
yeah.
Well, then can't we just plot that point? That gets us 1 point, right?
Yeah.
So 5, -2 is here. 1, 2, 3, 4, 5, down 2. That's the point they gave us, right? It's on our line. Oh, my bad. Thank you.
Which way would we?
5, -2 is here, right? It's on our line. Now, how do we find another point to graph our line? What?
Y equals -1/3. I don't know.
That's not the line we're looking to graph. That's the line we use to find the new line. We want to graph this line, right? We've got one of the points. Huh? How are we going to get another point? We need another point to graph this thing, right? That's 1 point that's on our line. How do we find another point?
I'm stuck.
Okay. You not see it?
Nope.
It's okay if you don't. We have slope, don't we? What's our slope? 3. So if I go up 3/1 like Tucker said, don't I get another point?
Yep.
Do you see how that's on our graph and is easier to graph than go all the way down to -17? Use the point they gave you and use that to find another point using slope, right? Now, if I continued doing this, I would eventually cross the axis at 17, right? But like, who cares? I just need to graph this thing. So I'm going to use the point that they gave me and then find another one using slope. Be clever, okay? I used the point they gave me, and then I found another one using slope. Done. Who cares about -17? Okay?
But what about the other line?
Well, if you wanted to, you could graph the other line. It doesn't say you have to. If you wanted to, you could go up to 6, right?
Yep.
And you could go down 1/3. And Mr. McCartney, if I keep doing down 1/3, we'll see that it does hit it at 90 degrees, or at least it looks like it does, right?
Yeah.
Here we are. So the black line's the original line. Never chase after a bus. Especially one that goes up at 90 degrees.
That's like why I miss school a lot. I miss the bus.
Yeah. Yeah. That's what I was
That's what I heard.
Yeah, my bus too. It
I
went
was surrounded by
sideways.
2 people at the same
Were you
time.
driving over a bridge when that happened?
No, no.
Okay,
Let's not
gotcha.
be practical.
Gotcha.
I went there and nothing happened. I was like, it's not going there. I went there, I wrote my name.
Hey, students. It's your boy.
It's your boy, right? Which also leads into another vine, which I won't say. Right. Find the slope of the equation of the line. Is what it says for this one. So we're on page 6. It's your boy.
It's your boy. It's your boy. MX plus B.
All right.
It's your boy. Slow.
That was funny. That was so funny.
That's Mr. Baxter's name.
Slope.
It's your boy Slope.
It's your boy. Slow.
That's right. All right. So it says find the slope. How are we going to find the slope of the given line?
That's what you tell. Yes.
How about pick 2 points? See how far they are apart, right?
1, 2.
So here's a point on the line. Here's a point on the line.
Whoa.
Looks like I go over 3 to the right, so that's positive. And I go up 3, so that's also positive. So our slope is 3/3, which means the slope is actually, if we reduce it, what? 1. Okay. Now we need to write the equation of the original line. So we know the slope is 1. So 1x. What's the y-intercept? Where does it cross the y-axis? Where does the black line cross the y-axis?
-3.
Yeah, so there's the equation of the original line, right? X minus 3. Slope of 1. That's where we got that from, right? You feeling okay?
Yeah. Sure.
So there's the original equation, right?
But where's the one come from again?
So now what we want to do is we want to draw, it says perpendicular, right? We want to draw a line that's perpendicular to the original, and it goes through that point. So it's what we were doing on the last page. We're just doing it graphically with a graph. So if I know I want a parallel line, or I'm sorry, not parallel, perpendicular, our equations aren't going to have the same slope, are they? They're going to have the flip and negate, right? So what happens when I flip 1? What do I get? Still 1, right? Now change the sign. Negative 1. So our equation is going to be negative 1x. And you can do the plus b thing and then plug in that point if you wanted to. Like we did on the last page, right? Plug in negative 4 and 0 for x and y and solve for b. Or you could use the slope and say, look, down 1 over 1, down 1 over 1, down 1 over 1, down 1. Where do I cross the y-axis? I cross it at
Negative 4.
-4. Well, it was one of his. Do I look? What? What? See how if I do our slope from the point, it crosses at -4?
You're interrupting my learning experience.
Also, Alex, like we did on the last page, so that works, right? Another way we could have done it, we could have said, look, I know this to be true. I'm going to plug in that point. What's that point? -4, 0. If I plug that in here, Alex, I could solve for b. So that's another way you could do it, right? I just did it visually. Use the slope, see where it crosses, right?
She's like, we can do it at the hospital. One time I threw up and I passed out.
Just Maddie things.
I'm here to learn.
Let's go down to the bottom one of this page.
3 times.
How do I find out what the slope of the original line is, the one they gave us? Yeah, you pick 2 points, right? And you do the slope. So I'm going to pick those 2. You might pick different ones, but the slope should be the same. Although it is kind of hard to tell where the perfect points are, right? So it looks like if I start at the top, I go down 2, and I'm going to the right 1, 2, 3, 4, 5, 6. So that's +6. So it looks like the slope of the original line is -2 over 6.
I got 5.
Did you choose different points?
Yeah.
What?
I got -2 over 5.
And you didn't choose those 2?
No.
Okay, yeah. So probably what happened is that it looks like it's a really nice point, but it's not, either for you or for me.
Yeah.
I would accept either because it's really hard to tell. So McCartney, don't worry about it.
I'll just choose your points.
That works for me. That reduces to this, so there's our slope, -1/3, right? Now we want a line that's perpendicular to this, so we have to flip and negate the slope, right? What happens when you flip a third? 3 over 1, right? Becomes positive. Right? Change the sign and flip it. So I changed the sign, now it's positive. I flipped it, it's now 3. You dig?
I'm so confused.
All right, so I found the slope of the original line, which is -1/3, right?
Oh no, I got that, but
Now to figure out the slope of the perpendicular, I know I have to flip it and negate it, right? Now we have 2 options. We can either go from the point up 3 over 1 and keep doing that to figure out where it hits the y-axis, or we can do algebra. I'm going to show you the graphical way first, visually, right? I'm going to go from the point, and I'm going to go up 3 over 1, and I'm going to keep doing that until I cross the y-axis, because I'm looking for that y-intercept, right? Well, it turns out we cross the y-axis right there. So that's going to be 2, 4, 6, 8, 10 at 10. So our y-intercept is 10. We could have also done that like the last page. So here's what we wanted, right? We also could have done this. I know it has to be this, right? I can plug in the point they gave us. What's the coordinate of that point? Looks like -5, comma, -5. So McCartney, I could have plugged in -5 for x and -5 for y and solved for b.
okay.
Like we did on the last page. I'm not going to do any more. But you see what I'm saying? I could do it that way as well. I get -15, add 15, I get 10, b is 10.
You got 3 over 1 by flipping it, right?
Yeah. Flip and change the sign. There are 2 ways to get 10. I could either do the slope over and over again, or I can do algebra. Me too. All right. Questions? How you feel? These?
These.
Do it. Do it.
That was so good. Do it again. No! Hey!
What's wrong with you?
Open gym. It's Thursday.
You imbecile.
I'm like, I missed mine.
This one's
It's
weird.
only the good vine. They
That
don't
one sucks.
That's right. Skip leg day though. Don't do that. All right.
We're done.
Let's look at this last page. This one right here.
Where's that?
We want it parallel and through that point. Easy. Here's parallel and through that, or I'm sorry, not parallel, perpendicular and through the point. Done. What's the equation of the red line? All the points on that line have something in common.
They're all 1, 2, 3.
Y equals 3.
Y equals 3.
That's it?
Every point here is y equals 3. 0, 3. Something else 3. I'm not going to count it. You see how they're all 3?
Is 3 your favorite number?
No.
Yeah, there's like a reason like every single
I try to keep the numbers small, and 3 is really good because it's not divisible by 2, right?
Whoa.
It changes things up, right? If I use 4, I might as well just use 2.
What's your favorite number?
My favorite number? I have lots of favorite numbers. I don't know what my favorite is, but my favorite single-digit number, infinity's not a number, is
Yeah, it's 2015.
Mine's 5.
9 is my favorite single-digit number.
I have a question.
Yes.
So when you think of a number, like, okay, this is really hard to explain.
Do I always think of 7?
Think of some numbers, like, do you think that some numbers are, like, prettier than other ones?
Yes.
Like,
What up?
27 is freaking ugly, but, like, 24
Let me tell you
is
about
cute.
28.
Like,
What are you talking about?
There's a thing called synesthesia where people will hear notes, like on a piano, and they'll see colors. So certain notes have certain colors. Same thing with certain days of the week.
I do that.
Oh,
Same thing
when-
with numbers.
Number 4 is
when
purple.
somebody will say, like, a certain thing,
Or it's
like,
yellow.
if somebody says something, I think of something else.
I
Like,
think of
when
numbers,
somebody
I think of
says
colors.
minute, I think of, like, a little blue penguin. Or, like,
Okay.
That's interesting, Corinne. I have a friend who's a synesthesia.
over here. That's a friend at
Right, that's association. I'm not sure if it's like synesthesia. Like, I don't have synesthesia, but I very strongly believe the number 4 is yellow, by the
like
way.
a second.
Oh, number 4 is
chicken.
Mhm.
Number 4 is
Or like
a chicken.
shut up.
Number 4
Dang,
is
leave
a
it.
chicken.
You like that, don't you?
Number
I do.
8 is a snowman.
There's nothing wrong with that.
It's not for
Number 1 is
Yeah.
an alligator.
Like, Tuesdays are always light blue.
No, I don't do that.
Oh, that's too
Always.
weird.
Well, no.
But number 4 being a
Tuesday
chicken.
is my great grandma's house because I used to go
What
Corinne,
is
that's
going
interesting.
on?
Can you make a list of all the associations? Can you do that for me? That'd be so dope. I want to have that. So when I teach math, I can just like, okay, everyone, imagine a blue penguin. We're talking about seconds here, right?
No,
Make me a
second
list.
is a piece of chicken.
Wait, seconds are a chicken? What's the blue
Yeah.
penguin? Minute?
A little blue penguin is a minute.
Okay.
And like the number 2 spelled out is like a little stuff.
Yeah, there was
like
a word
dog
in
or
here.
Make me a list, please.
I
Fine.
got my slim bag in here.
All your makeup's gone.
It is. I took it off because I just didn't feel like wearing it anymore.
That's fair. I wish I got to see your costume. Hi, Chloe!